Are your enemies completely deaf and blind? Let's fix that. We're building an AI that can hear, investigate, and hunt. I'll show you exactly how.
Okay, we need our enemies to actually detect sound. For the AI to truly react, we'll need to generate that sound first, and our player character will be the source. The player character needs a number variable called noise range.
We need a visual indicator. Use a shape painter object. I've already set one up called raycast. Under the player group, add a noise gen group, add a condition the beginning of the scene. Then create raycast object at player X and player Y and add an action to link it to the player. Add an action to draw a circle. Its center will be at the player.x and player.y position. For the radius, use player.noiseRange. Change raycast's filling opacity to 0. Now, add a condition, player is moving. If true, set the noise range object variable on the player to 30. That's for movement noise. Then add another condition, player is moving, but invert it. When the player is still, set their noise range variable back to 0. Finally, for big noise bursts, add a touch or left mouse button is down. This triggers when the player fires. Set the player.noiseRange to a much larger 275.
All right, we've got the noise generation working, but we need the enemies to detect the noise. And for that, defining their max detection radius is crucial. Open your enemy's properties. Add a variable, hearing range, and set it to 50. Back in events, we'll add a hearing group. Add the condition at the beginning of the scene. Then a for each instance of sub-event and select your enemy object. Next, add an action, create raycast object at enemy X and Y. Immediately link that raycast object to the enemy. Finally, for visual debugging, add a draw painter group. Add an action, select the raycast, draw a circle at enemy X and Y, then set its filling opacity to 0.
Okay, our enemy AI is totally ready to take action now. When it's in hearing range of any noise that the player makes, it'll move to investigate.
First, open your enemy object's properties. We'll need two new variables here, investigate X and investigate Y. All right, let's set up the logic. Create a new event group, call it investigate. Inside this group, we'll use a repeat for each instance event. Add a sub-event at our primary condition here. Make sure the enemy state is not equal to dead. Now, add the compare two numbers condition. This is where we check if the distance between players X and Y and enemies X and Y is less than or equal to player.variableRange plus enemy.variableRange. This calculates if a player's noise reaches our enemy's ears. Add an action, change the enemy's state variable to investigate, and then update investigate X and investigate Y to the player's current X and Y position. This gives our AI a clear target. Next, a new event within our investigate group. Add an and condition. Inside that and, we need two checks. First, enemy state equals investigating, and second, enemy has reached its destination. Crucial detail here, add a trigger once here. If both are true, reset investigate X and investigate Y back to 0. Finally, one more event. Condition enemy state equals investigating. Then the action, move the enemy to the variable values investigate X and investigate Y. Okay, let's preview what we've built. You'll notice our enemies just move to where they perceive the player to be, but don't actually know if the player is truly there. That's because, frankly, these enemies are blind. They can't detect if the player's actually there. So to fix this flaw, we need to give them proper sight. Open your enemy's properties and add a variable raysize, set to 300. This is crucial. Back in our events, create a new group, custom raycast. Inside this group, create a subgroup, beginning of the scene. Now add a condition, select at the beginning of the scene. Then add a repeat for each instance sub-event, selecting the enemy object. Inside repeat for each instance of enemy, add action create object test ray at enemy.x, enemy.y. Next, add a sub-event. For its condition, check if the distance from test ray to enemy is below 30 pixels, and add an action to link the enemy to the test ray object.
Create a new group and name it position. Inside this group, add a repeat for each instance event, selecting the enemy object. For the condition, check if the enemy's state variable is not equal to dead. As a sub-event, add another repeat for each instance event, this time selecting the test ray object. For the condition, select take into account all enemy linked to test ray. Now for the actions inside this sub-event, first, change the position of test ray E, set X position to enemy.x and Y position to enemy.y. Second, rotate test ray E towards player.x and player.y at a speed of 0.
When we preview the game, you'll spot a tiny red square on each enemy. This initial test ray object rotates towards the player every frame, acting as our enemy's eyes. But here's the problem. Its vision range is too short. We need to dynamically adjust enemy vision based on obstacles in the level, like walls. Let's set up the logic. First, open the test ray object and add a variable called wall hit and set it to 0. Create a new group and name it custom raycast site. Inside this group, add a repeat for each instance event and select the enemy object. For the condition, select take into account all enemies linked to test ray. For the actions, first change the width of test ray and set it to 0. Second, change the variable wall hit of test ray and set it to 0. Add another repeat for each instance event, selecting the test ray object. Then add a while event. Add an and condition. Inside the and condition, check if variable wall hit is equal to 0, the width of test ray is less than enemy.raySize, and if the enemy's distance to player is below 600 pixels. Add an action in the repeat block, change the width of test ray, and add 5. Next, as sub-event to the while event, add a repeat for each instance event, selecting new sprite. This represents the walls. Inside this repeat for each instance of new sprite event, add a condition. Test ray is in collision with new sprite. For the action, change the variable wall hit of test ray and set it to 1. Finally, add another sub-event. For its condition, check if test ray is in collision with player. For the action, change the variable wall hit of test ray and set it to 0.
Let's run a preview. See how our test ray's width now dynamically adjusts relative to the player's distance? It smartly checks if there's a wall between our enemy and the player. Pretty cool. Now that our enemies can actually see the player, the big question is, what should they do when that happens? That's next.
All right, almost done. Just a few critical events, and then our enemy AI is fully functional. First, enemy found. Create this group. Inside, repeat for each instance of your enemy object. Conditions, an OR block checking if enemy state is investigating or patrolling. Sub-event, repeat for each instance, test ray. Conditions, enemy is linked to test ray, and test ray is in collision with the player. If true, actions, enemy, stop, remove all forces. Then set enemy state to attack. Next, when the enemy doesn't find you as expected, our enemy not found group. Repeat for each instance of the enemy. Conditions, enemy state is investigating, and enemy has reached its destination. They arrived, but you're not there. Now for its sub-event, repeat for each instance test ray. Conditions, enemy linked to test ray. Listen closely. Check if test ray is not in collision with player. Yes, this means the ray is not hitting the player. If conditions are met, add the actions, enemy, rotate toward an object, player at 0 degrees per second, set maximum speed on the path to 0, wait for a second. Finally, set enemy state to patrolling, a specific AI decision point. And finally, loss of target mid-attack. Repeat for each instance of your test ray. Conditions, check if test ray is in collision with player, then invert this condition. For its sub-event, repeat for each instance of the enemy. Conditions, test ray links to enemy, and enemy state is attack. If true, add the actions set enemy state to investigate. Capture player's last position, set investigate X to player.x and Y to player.y. AI memory activated.
boost its maximum speed on the path to 150, and move to a position using enemy.investigateX and enemy.investigatey.
Our enemies now actively hear and see the player. Hear a noise in range? They investigate. Attack aggressively if the player is found. Lost sight? They track your last known position. Spotted there? Combat re-engages. Vanished? They smartly return to patrol. But what's the real game changer? We're finally giving them the power to fight back!
Open your enemy's properties, add a hold point. Next, weapon properties, place a muzzle point. Head to behaviors and add the fire bullet behavior. Create a new attacking group. Inside, add a repeat for each instance for enemy. 2 conditions. Enemy's state variable must be attack. Create a sub-event and add trigger once. For actions, first make the enemy rotate around the player at 0 degrees per second. Then, start a scene timer named attack. At the beginning of the scene, we'll dynamically attach guns. For each enemy instance, create an object, our obj shotgun E, right at enemy.x position and enemy.y position. Add a condition if obj shotgun E is within 30 pixels, link two objects, enemy and obj shotgun E. Then add a for each enemy instance event and a for each shotgun E sub-event. For the condition, add a condition, take into account all linked objects, update its position and angle, set its x and y to enemy.pointExitHold and enemy.YAtHold, and its angle, enemy.angle. Create a shoot group. For each enemy, check if its state is attack. We only shoot if our attack timer is greater than 0.5 seconds. Use the take into account all linked objects condition and check if the testRayE.wallHit variable is not equal to 1. For the actions, select your weapon and choose fire bullet from shotgun E.pointExitFire, shotgun E.pointYatFire, select the bullet object, set the target to the player, and the bullet speed to 500.
Okay, one final tweak for your patrol group. This prevents total AI confusion. Go back to your patrol group, add an AND condition, then inside it 3 more. Check if the state variable isn't dead, investigating, or attack. This makes sure patrolling doesn't interfere with other states. Now let's preview what we've built. You'll see your AI in action. They patrol, investigate, chase, and actively attack when in range. This AI system can integrate into many different types of games. If this video helped your game dev journey, leave a like and subscribe. Got tutorial ideas? Comment below, I'll totally help out. Until next time, keep creating.